Hello guys, good evening everyone, and welcome back to 360DigiTMG's domain analytics program. We have started the transportation domain from the last class. Last class is the very first class, and the last class that we have discussed where exactly we can apply the machine learning algorithms when it comes to transportation. How can we improve the transportation using the different machine learning algorithms, and where exactly we are already started using the machine learning or artificial intelligence that we have discussed all those applications in the last class. And today's session we'll be discussing the second day of the session when it comes to transportation data analytics. So in this session we'll be discussing about CRISP-ML methodologies. What exactly the CRISP-ML methodologies? Where we will be using the CRISP-ML methodologies? What is it? All those things we'll be discussing. Before getting into the session, we'll simply go through what will be the agenda of this session. So when it comes to the agenda of this session, first we'll be having the stages of analytics. So it could be any domain. You'll be having 4 stages when it comes to analytics. What are those stages? We'll go through step by step, and what exactly we'll be doing in that particular stage that we will discuss. And then we have CRISP-ML methodologies. When we are talking about the CRISP-ML methodologies, these are the phases, irrespective of any domain, whether it could be HR, whether it could be financial analytics, or whether it could be agriculture analytics. It could be any domain. So whatever the data science project that we are doing, we will be implementing in this 6 phases. We'll be implementing in this 6 phases. What are those phases? We'll discuss in detail one by one. These are called CRISP-ML. What is CRISP-ML? Cross-industry standard process. Machine learning quality assurance. So these are the phases we'll be applying to any data science project, irrespective of any domain. We'll be going through those phases in order to improve the model accuracy. And then we will be seeing what is the inferential statistics. Normally, whatever the data that we will be taking, it is a kind of sample. So we won't be able to apply analytics on whole population data. So it is not possible. So what we will be doing, we'll simply capturing the data or sampling the data, or simply taking one sample out of this whole population, and then we will be applying our data on whatever the analytics that we are applying, statistics we'll be applying on the sample data, and we'll try to bring out some inferences. That only we'll be calling it as inferential statistics, that we'll be discussing in detail. And when it comes to machine learning models, we'll be having different types. Those are unsupervised learning, supervised learning. Nowadays we'll be having semi-supervised as well. Semi-supervised. And what are those? When exactly we'll be going for unsupervised learning, and when we will be going for supervised learning? What exactly those we'll be discussing in detail. And then we will be having data split. How data split will be happen when it comes to unsupervised and when it comes to supervised. So what is the difference? We have some functions to evaluate the whatever the accuracy that you are getting. Is it good accuracy or not? In order to check that, we will be having the error functions. So for different algorithms, we'll be having different error functions. For classification, we have different error function. For regression, we have some error function, different error function. What are those error function? How those error function will be helpful to determine the accuracy of that particular model? We'll be discussing that in detail. And then we'll be having overfitting and underfitting. So whatever the accuracy that we are getting when it comes to training data and testing data, using those we'll be getting overfitting issues and underfitting issues. What are those underfitting and overfitting that we will be discussing, and how can we overcome overfitting issues and underfitting issues when it comes to regression, or as well as classification techniques we'll be discussing in detail. So this is the agenda of today's topic, that is CRISP-ML methodology. Let's get into, without wasting any time, let's get into the very first point of the today's session is stages of analytics. Yeah. Here, it could be any domain, irrespective of a domain. It is not just for the transportation. Since we are discussing about the transportation domain only, that is what I have mentioned, but we can use the same data analytics, same stages of analytics in any domain. So here we'll be having four. First, descriptive analytics, and then we have diagnostic analytics and predictive and prescriptive. We can also call it as, in order to remember in a sequence, you can say D square and P square. Descriptive, diagnostics, predictive analytics, and prescriptive analytics. What happens in each domain, I mean, each stage. So whenever we are talking about the descriptive analytics, what happened? So it will be dealing with what happened. When comes to diagnostic analysis, we'll be talking about why something happened. We'll be having a large amount of data. In that case, you can figure it out by doing some visualization, and by analyzing data, you can understand what is the reason behind it. Something happened, why it is happened, what is the reason behind it. So in this, we'll be talking about why something happened. So if we continue the same thing, what is likely to be happen? So in future, what is going to happen with this kind of inputs that we'll be analyzing when it comes to predictive analytics. In this predictive analytics only, we'll be having algorithms or models, you can say, machine learning models. Machine learning models, those are supervised, unsupervised, supervised models will be having, unsupervised models will be having. Using these, we will be doing the prediction, what is likely to be happening in the future. So based on these, all the inferences, we will be doing the business decisions. Business decisions. What is it? What is to be done? In this stage, we'll be discussing about what is to be done. So that whatever thing is happening, if it is happening in the wrong way, in that case, how can we avoid that? What are the business decisions that we can make so that we can avoid this? If something is happened, good way, in that case, what we can say, how can we continue that? Those are the business decisions that we will be making using this analytics. Irrespective of any domain, we'll be having the four analytics. That is one, descriptive analytics. Let's say you have some loss, you got some loss in your company. You got some loss in company. Whenever you're talking about the loss, in that case, you will be having the data, historical data, you'll be having historical data, right? Each, I mean, any project that you are talking about when it comes to domain data analytics, or when it comes to data science, so you should be having data, historical data. Based on those historical data only, we will be doing the predictions, we'll be doing the business decision. All will be happens based on the historical data only. If you don't have any historical data, we won't be able to do anything. So here we'll be having, let's say you have some losses happened in your factory or company in manufacturing. So what happened? You got loss. Why is that happened? You will be having data. By going through the data or analyzing the data or doing some inferences. In that case, you will be finding out why that particular thing is happened. If you continue that thing, so what is likely to be happen in the future? So we'll be getting the loss, or maybe you're getting into the bankruptcy or something like that. We can do the predictions. After doing the prediction, what are the business decisions that we can make? Those are the business decisions we'll be making based on these different stages. So this is all about stages of analytics. Here we'll be having the four stages those are descriptive, diagnostic, predictive, and prescriptive. And then we will be having crisp MLQ. In CRISP MLQ, what is CRISP MLQ? Cross industry standard process. Cross industry standard process. It is saying cross industry. Industry could be anything, domain could be anything. You'll be applying the same CRISP MLQ methodology. Cross industry standard process, machine learning, quality assurance. This is the abbreviation for CRISP MLQ. Previously, we used to have CRISP DM. Cross industry standard process, data mining. Data mining. Previously, we used to have this. In this, we don't have monitoring and maintenance. This CRISP DM methodology, we won't be having. We didn't have monitoring and maintenance, and when it comes to CRISP ML methodology, this monitoring and maintenance has been added. So why do we need to discuss about these things? In order to improve the accuracy, in order to improve the accuracy of the model, it is absolutely necessary to follow one sequence. That sequence only will be calling it as CRISP MLQ methodology. What are those sequences? The very first one, business and data understanding. Once you have received problem statement saying that what you are getting losses in that particular plant or manufacturing plant, and that could be in production, something. It could be anything. You are getting the losses. So what you have to understand first, you have to understand what exactly the objective, what we have to support to do. We are getting losses. Why we are getting losses? And whatever the data that they are providing, we have to have an understanding about the data. That is the very first, stage when it comes to CRISP MLQ. You have to have an understanding about that business and the data understanding. Whatever the data that they are providing, you should be having a clear understanding about the data. Once you do know what are the project objective, in business understanding, we have to know what could be the objective of the project and what are business constraints you will be having. So once you start working on that, what could be the constraint? What could be the constraint that you can face? So if you have this idea, in that case, you can simply go with it. Data understanding. Whatever the data that they are providing, you should be having clear understanding about each and every feature. If you don't have an understanding about those features, in that case, you won't be going to build better, better model. So in order to avoid that, you should be having good understanding about the data. And then once you have the data understanding, you can simply go with the data pre-processing. In that case, what we will be doing, simply go through, for data pre-processing, we'll be having one module that we will be discussing in the next session in clearly what are the pre-processing techniques we'll be having for different. If it is structured data, what are the pre-processing techniques we'll be having? If it is unstructured data, what kind of pre-processing techniques we'll be having? We'll be having different pre-processing techniques that we will be discussing in the next session. But here in the second phase, we'll be having data preparation. So whenever you are collecting the data, you'll be having so many anomalies. Anomalies mean in the sense, the data might not be useful, or maybe some duplicate data might be having, or the same entry you might be giving like multiple times. There might be missing values in our data. All those things comes under anomalies. You have to remove those anomalies in order to do the model building. For that, we will be having the data preparation. That is the second phase of the CRISP MLQ method. In that, we will be doing the data preparation. So we'll be cleaning the whole data, and then we'll be supplying the data to the model. Once the data preparation is done, we will be supplying the this data to the model building. What we'll be doing with that, based on the data set, what kind of data set we have, whether it is having label in our data or not. If you have a label, in that case, we'll be going with supervised. If you don't have any label, in that case, we'll be going with unsupervised learning, and we'll be feeding the data to the machine learning. Based on that, we will be getting the output. what happens when comes to unsupervised learning, what happens when it comes to supervised learning, what kind of output we'll be getting, that we'll be discussing in a second. So in third phases, we'll be doing the model building. And if you want to tune, I mean, if you have any overfitting issues or underfitting issues, in that case, we have to tune tune that particular model so that we can get better accuracy. So in third phase, we'll be doing the model building, and then we'll be having the model evaluation. Whatever the model that you have built, whether it is performing good or not, what kind of accuracy that you are getting. Those are all the things that we will be doing when it comes to model evaluation. Evaluating the model, how good your model is, learn the pattern, how good your model is performing. That we will be doing when it comes to model evaluation. And once it is done, we'll be going with. So you figured out, yeah, a model is performing good. In that case, we'll simply doing the deployment. What is deployment? Whatever the model that you have done, I mean, built based on different feature, will be giving to the client. The client will be deploying that model into different web. Maybe they will be using for internal purpose, or they may be make it available to the public, so that whatever the model that you have built, it will be getting into the deployment. But means it will be used for public. So whatever the feature that you have built, I mean, based on which feature you are building, they can simply enter those features. I mean, it depends on which model you are building. If it is agriculture project and you are building the model to predict what kind of crop that particular farmer or that particular regional farmer should go for, in that case, you will be building some model. Same feature they have to input, and they have to come up with, I mean, it will be predicting one output saying that you have to go with this particular crop, something like that. We'll be doing the deployment. And then monitoring and maintenance. As time passes, maybe data might might not be useful anymore. Maybe data trend might be changing. In that case, each and every time, if you are getting the new data, in that case, you have to build model based on the new data, and again you have to deploy. That is, we will be having when it comes to monitoring and maintenance. So these are the 6 phases we will be having when it comes to any data science project, irrespective of any domain, cross-industry, standard process, machine learning, quality assurance. So we'll be applying the same 6 phases irrespective of any domain. So these are the crisp ML phases we'll be having. First, once you have received the data or the problem statement, you will be understanding business, and then you will be doing the business understanding, data understanding. Once you understand the data, business understanding, then you will be going with the data understanding. Then we will be doing the pre-processing, and then we will be doing the model building. Once model building is done, we have to check, we have to evaluate whatever the model building that you have done, is it performing good or not. Once it is done, we will be doing the deployment, and then we will be doing the monitoring and maintenance. So these are the 6 phases we'll be having when it comes to crisp ML. Yeah, so when it comes to machine learning models, we'll be having 2 types. One is unsupervised, and one more is supervised. And we have semi-supervised as well, but we will be discussing only supervised and unsupervised. So what happens in unsupervised learning? We'll simply, right after doing the pre-processing, done pre-processing. Once pre-processing is done, we'll be passing the data or the historical data, any data, to machine learning model. What does machine learning model do? It will simply go through each and every pattern. So whatever the entries that you are giving, entries means number of rows, and features means number of columns will be having. Whatever the entry or the data that we are feeding to the machine learning model, what it will do, it will simply go through each and every data, and it will find out the patterns. Based on those patterns, it will come up with some rules. Based on those patterns, it will simply come up with some rules. If we are giving the new data to the machine learning model, based on this rule only, it will do the prediction. prediction. It will simply segregate when it comes to unsupervised. Whether you are doing, let's say, you have a data frame of customers, and if you want to do the segmentation of those customers based on what their income, you want to segment into like a high income customer, low income or medium income customers. For that, we'll be passing the data into the machine learning model. Based on those, it will simply segregate, or it will do some rules. It will form some rule for high income customers, low income customers, and medium income customers. With those rules, if you pass new data to that particular machine learning model, it will simply predict, saying that, yeah, whatever the data that you have imported, given input, whatever the input that you have given, based on that, it will simply predict, yeah, this belongs to the low budget, low income criteria, or high income criteria, or medium income criteria, based on these rules that it is formed based on the historical data. So this is when it comes to simple, when it comes to unsupervised learning. And then we will be having the supervised learning. What happens in supervised learning? Whatever the data frame, right after, see, whatever the model building that we are doing, it should be right after the pre-processing. Once pre-processing is done, then only we'll be going with model building. So what happens in this? We are simply right after the pre-processing, whatever the data frame we'll be having, we'll split into train and test. When supervised, we'll simply split into train and test. So before that, we have one more thing you have to understand. What is when we will be going with supervised, when we will be going with unsupervised. When you have a data frame and you don't have any labeled data. What is labeled data? Let's say cancer data or COVID data we'll be having. So we have different features, whether that particular person has cough or body pains or taste. So these are the different features. Based on these features, we are deciding or we are predicting whether that particular person has a COVID or not. This is the output column. That particular COVID positive or negative, positive or negative. These are the output data. If you have an output data, in that case, we'll be calling it as labeled data. When you have an output column that is label, is called as a label data. When you have a label data, we'll be going with supervised. When you don't have this, only features we'll be having. In that case, what we'll be doing, we'll simply cluster into different groups based on the similarity of those input. We'll simply cluster into different groups. This is when it comes to unsupervised learning. Not just cluster, we'll be having other techniques as well. But when you don't have label data, in that case, we'll be going with unsupervised learning. If we have a label data, in that case, we'll be going with supervised. So what happens in supervised? Whatever the data frame we'll be having, we'll simply split into train and test. We'll simply split into train and test. So whatever the train data will be having, based on that train data, we'll be training the machine learning model. Using the training data, we'll be training the machine learning model, and then we will be passing the validation data or test data, I can say it. We'll be passing the test data to that particular machine learning model. Based on that, we'll be doing the predictions. So this is when you have a machine learning model without any, less number of parameters. Or you can simply say parameters. When you have a less number of parameters, when you have hyperparameters also you can call. When you have a more number of hyperparameters or parameters, in that case, what we will be additionally giving one validation data set. Validation data set. What happens when you have a high number of parameters? So whenever you are tuning the model, you don't know where exactly which parameter, at which parameter it will be performing better. So what you have to do, you have to keep changing the parameters. In that process, you might be having, the data leakage might happen. while doing the hyperparameter during testings, in that case, data might, data leakage might happen. To avoid that, we will be using validation data set. Same data frame we will be splitting into train, validation, and test. So normally we'll be taking 60%, 20%, and 20%. And when you are just training and testing, in that case, training data will be 80%. So it is not compulsory. This is not a thumb rule. Based on the amount of the data you will be having, based on that, you can simply go with different percentages. If you have 1 million data, in that case, you can simply go with 90% train data and 10% test data. We don't have any thumb rules for that. Based on the data frame, we can simply go with different ratios. So here, I'm going with 60% train data, 20% validation, 20% test. What happens when you have a high number of, more number of hyperparameters? We have to train the data, train the machine learning model based on train data, and we don't know at which parameter it will be performing best. So we'll be passing that parameter and we'll be checking the accuracy. We'll be passing one more parameter and we'll be checking the accuracy. In this process, the validation data might leak to the machine learning model. What happens when it is leaked? Machine learning simply learn the whole patterns. It will simply copy paste or simply by heart those. So whenever you are calculating the validation accuracy, it will always give 100%. Since it knows the whole pattern, all the pattern it will know. So it will be giving that. So to avoid that, we will be using the test data. So it is completely new data. In that case, we'll be supplying the test data to check the accuracy of that particular model. In order to avoid leakage, we will be using the test data, validation, training, and testing. 3 parts will be splitting. So this is how supervised learning works. Same data split, model evaluation, and tuning. So whatever the data we'll be having, we are splitting into training, validation, and testing. We'll be training the model using building. We are building the model or training the model. It's pretty much same. It is same. So we'll be training the machine learning model using the train data, and we are supplying the validation data to check the accuracy. If it is okay, it is giving good accuracy, in that case fine. Otherwise, we'll be changing the hyperparameters or parameters. We'll be changing the parameters and checking whether it is performing good or not when it comes to other parameters. Like that, we'll be checking different parameters. At which parameter it is performing better. And you come to know this parameter it is performing well. In that case, we'll be building the model using that parameter. We'll be building the model using that parameter, and then we'll be supplying the test data to check the accuracy of that particular model. If it is still giving the good accuracy, in that case, you can say that whatever the accuracy that you are getting are genuine accuracy or the good accuracy. So this is data split. Simply splitting the data into training, validation, and testing when you have more number of hyperparameters. And when it comes to error functions. So what is error function? Done model building we have done. So whatever the model building that we have done, is it how can we find out the accuracy of that particular model? How good our model is performing? For that, we'll be having the error function. We'll be having error function. So when it comes to supervised, we have two main model building that we'll be doing. One is classification, and one is regression. When it comes to classification, when your output data is categorical, so we have talked about the label column, right? Whenever we are going with supervised, the data frame that has been given, it should be having label data, that is output data. Whenever that label data or output data is categorical or discrete, in that case, we will be calling it as classification case. Whenever you have an output data that is in categorical or discrete form, in that case, we will be calling it as classification. So for that classification, we'll be having error function, that is confusion matrix. Error function when it comes to classification case, we'll be having confusion matrix. What happens in confusion matrix? What exactly the confusion matrix? It is just a matrix. It will show you how many classes, whatever the output label or output or labeled column will be having in that classes. Let's say, what are the classes here? COVID. In COVID output, we have positive and negative. Only two output will be having. These two will be calling it as classes. How many classes has been perfectly classified, correctly classified, or how many misclassified? That data will be available when it comes to confusion matrix. How many classes correctly classified, how many classes misclassified? These data will be available when it comes to confusion matrix. So what happens here? Here see, this is the predicted cases and these are the actual cases. Predicted cases will be having predicted case means using the model building, whatever the prediction that you have done, these are available in a predicted case. Actual cases mean whatever the historical data will be having, in that also we will be having the output, right? Those are the actual cases. So we'll be seeing whether whatever the prediction that we have done, is it correct or not. Let's say if the data that is a predicted one, it is an actual one. If actual case is positive and you have also predicted positive, in that case we'll be calling it as true positive. When actual case is positive and the predicted case also positive, when it comes to COVID cases I'm talking about, both are positive, in that case we'll be calling it as true positive. When actual case is negative and we predicted as a negative, the prediction that we have done using the machine learning model, it is also negative, in that case we'll be calling it as true negative. When actual case is positive and we have predicted negative, when actual case is positive, when we have predicted negative, in that case we'll be calling it as false negative. Normally that particular person has a COVID, but our model predicted that he doesn't have a COVID. That is a false negative cases. And one more, we have actual case is negative and the prediction that we have done is positive. In that case we'll be calling it as false positive. We got positive, but it is false. When actual case is negative, but the prediction that we have done is a positive, in that case we'll be calling it as false positive. So these are the different cases we'll be having. Based on this, we can calculate the accuracy of the model. You can simply check true positive. The patient with the disease is told that he has a disease. He has a disease and the prediction is also has a disease. In that case, we'll be calling it as true positive. When patient doesn't have a disease and the prediction also came out, it doesn't have a disease, in that case, we'll be calling it as true negative. False negative, patient has a disease, but prediction is saying not having a disease. In that case, false negative. When it comes to healthcare analytics or life science analytics, these are detrimental. Why? Because that particular person has a cancer and you are saying you don't have any cancer. The prediction, that model you have done, using your model, you have done prediction saying you don't have a cancer. In that case, it could be detrimental, right? The person will relax. So you don't need to go through any treatment. So he might be realizing that he has a cancer after so many long times. After long time, in that case, maybe he is in first stage at the time you have done the diagnosis. And now it is in the last stage. So it will be very detrimental cases. When it comes to healthcare analytics and life science analytics, we should be very careful when it comes to false negative. And with the patient with no disease, and we have predicted that that particular patient has a disease, in that case, we'll be calling it as false positive. So these are the cases, different misclassified cases. So here we'll be having true positive and true negative. These are the correctly classified cases, false positive and false negative. These are misclassified cases. And based on that, if you want to find out the accuracy of the model, simply true cases by total. This will be the accuracy of the particular model. What are the true cases? True positive plus true negative by false positive and false negative plus true positive plus true negative. Total cases. True positive plus true negative, true positive, false negative, false positive, and false and true negative. This is the accuracy of that particular model. Based on that, we will be deciding what is the accuracy of that particular model. So if you want to, it is accuracy. If you want to find out the error, if it is, accuracy is 80%, what could be the error? It is 20%. And you can simply say 1 minus accuracy. So normally we will simply represent the accuracy in between 0 to 100. 0 to 100 or 0 to 1. If 80% is accuracy, in that case, you can directly say error is 20%, 1 minus or 100 minus. So this is the error function when it comes to classification. When Y is categorical or discrete, then only we'll be going with classification case or confusion matrix. This is the error function when it comes to classification case. Yeah, similar to that. So we'll be having precision error function when it comes to confusion matrix. Based on that only we will be deciding the precision. What is the precision? Let's say you have done model building, you have deployed the model, and some random person came to check whether that particular person has a COVID or not. Based on some feature you have built the model, right? The same feature he'll be entering, and he will check whether he has a disease or not. Probability of correctly identifying a random patient with a disease having a disease, that we will be calling it as precision. Some random guy coming and checking whether that particular person has a COVID or not. Anything that could be illness is anything. Whether that particular person has a disease or not. He has a disease, but he wants to check. He doesn't know, but he wants to check. So if we are correctly classifying that a particular person having a disease as having a disease, in that case, we'll be calling it as precision. And then we have a sensitivity. It is also called as recall or hit rate or true positive rate. What is it? So let's say you have total 300 cases. In that 100 positive cases, you have 200 negative cases that we have. Among those positive cases, among those 100 positive cases, how many of you predicted as positive? Among those 100 positive cases, how many of you predicted positive? That we'll be calling it as sensitivity. Proportion of people with the disease who are correctly identified as having a disease. Positive, that is having a disease, and you correctly classified those. How many of you correctly classified? That will be calling it as sensitivity. Among those negative cases, how many of you correctly classified as a negative? That we will be calling it as specificity. Among those negative cases, proportion of people with no disease being characterized as not having disease, that portion we will be calling it as specificity. And then we'll be having false positive rate. That is 1 minus specificity, we'll be calling it as false positive rate. And whenever you don't, if you are working on some analytics, some domain, you don't have a knowledge of that particular domain, you don't know which which one we have to consider, whether you have to go with precision, whether we have to go with recall. If you don't have an idea about that, in that case, you can simply go with F1 ratio. It will simply balance both precision and recall. So that is the formula for. So F1 ratio, it will simply balances precision as well as recall. Yeah, it will simply balance both. You can simply go with the F1 ratio. It will nearly whatever the F1 value will be getting, it will be near to the accuracy of that particular model only. So you can simply go with the F1 score. Yeah, whatever the confusion matrix that we have discussed in now, it is for classification case. When you have classification, and how can we say that? How can we find out the accuracy using the error terms? And when it comes to regression, you have error function. We have different error function when it comes to regression. Let's say this is the actual data and the forecast based on model. This is the model 1. Error from model. What is the error? Actual data minus predicted. That only will be calling it as error, right? So it is 100. It is 100 and it is 101. What is the difference we'll be having? 1. That is the error term. Actual data is 200 and the forecast or the predicted using the model will be having 99 or 99, that is minus 1. If you calculate the mean of all those, it will always equal to 0. That doesn't mean we don't have any error, right? We have an error, but mean of those is 0. To avoid that, what we'll be doing? So here, we'll simply square it. So that it is not giving the actual picture, right? Whether we have any errors or not. It will simply say it is having the error 0. So we won't be taking that. Instead of that, we'll be going to mean square error. Instead of going for mean error, we'll be going with mean square error. So what happens in mean square error? We'll simply square it. We'll simply square it. In that case, what we have here? 4 error. So in this perspective, it is fine. When you have 1, 1, 1, 1 and you square it, you'll be getting 4 as error. Yeah, it is exactly the same error that we'll be having. But when it comes to this 2-digit number in that case, will you get the same when you square it? When you square it, how much you'll be getting? 400 you are getting. But is it the actual error we'll be having? No. This is the actual error we'll be having. To avoid that, what we'll be doing? We'll be going with root mean square error. What happens in square error? Units get squared and the value is also getting squared. To avoid that, we'll be applying root. In that case, what happens? Whatever the error term we'll be having, we'll be bringing back to the normal form. Actual error. And the unit that we are getting squared, that also we can avoid when it comes to root mean square error. So mostly when we are working on the regression, we'll be going with root mean square error. And then we'll be having the mean percentage error and mean absolute percentage of error as well. Then we will be using to remove the units completely. In that case, we'll be going with mean percentage error or mean absolute percentage error. So these are the different error terms. These are the different error terms when it comes to regression case. So what is the accuracy? Accuracy plus error term will be getting as 100%. So we'll be describing the accuracy in between 0 to 1, or you can say 100%. So accuracy and plus error, that will become is equal to 100, right? So, and then we will be having overfitting and underfitting. So what exactly the overfitting? Let's say you have a training when it comes to classification. Training accuracy will be having, since we are splitting the data into train and test, right? We are splitting the data into train and test. So we'll be having the training accuracy, we have a testing accuracy. When training accuracy is high and testing accuracy is low, if you have too much difference when it comes to training accuracy and testing accuracy, and training accuracy is high, like say 90%, and it is just 50% something. In that case, what happens? We'll be calling it as overfitting. We'll be calling it as overfitting, also called as a variance. When training accuracy itself low, training accuracy itself low, when that case testing accuracy obviously it will be low. That case we'll be calling it as underfitting. It also called as bias. Underfitting is also called as bias or bias. So how can we avoid this? We'll be having different techniques. Those are called as, for overfitting, we'll be going with regularization techniques. What are those regularization techniques? So it is a huge topic. It is not possible to wrap this in 1 hour. So it is a regularization topic. Regularization techniques we'll be having. Hyperparameter techniques also will be having. When it comes to underfitting, when data is not performing good on training data itself, training with using training data itself, in that case, whatever the feature that you are taking may or may not be giving the actual picture. So we have to go with, we have to add new features so that it will give you, it will be giving information to predict that particular output. So we have to add new features into our data. So like that, we'll be having different techniques. So it is a regression when it comes to regression, and when it comes to classification, it is a underfitting case. Let's say when it comes to regression, what we will be doing, let's say this is our data frame, this is our data frame, and but the prediction that we are using this is non-linear. Whatever data that we are taking, that is a non-linear, and you are applying the prediction using the linear. That doesn't make any sense. In that case, what happens? The error terms that you will be having, error is too much. Too much error means whatever the training accuracy will be having is very less. When training accuracy is very less, in that case, we'll be calling it as underfitting. Of course, you will be getting that right. When you have a nonlinear data and you're applying the linear as a prediction, in that case, you'll be getting so much error. And if you have a non-linear data and you're doing the prediction using the non-linear only, in that case, you'll be having less. You'll be having less error. In that case, we'll be calling it as good fit. You can call this as a good fit. And then one more we have. It is a nonlinear data, and it just learning that pattern, and it will go each and every data point. Wherever there is a data point, it will go each and every data point. It doesn't mean that performing good. It is not performing good. It knows the patterns. So it will simply go through each and every pattern. In that case, what happens? It will be getting 100% accuracy. Training accuracy will be getting 100%. So normally this is not possible. When you are getting 100% accuracy, it is overfitting. We'll be calling it as overfitting. So similar to the classification case, you can see here, there are so many misclassified cases. This is one class and this is one class. And you can see there are so many misclassified cases on the right side. So in this case, we'll be calling it as underfitting. So if you do some hyperparameter tunings, or if you do some pre-processing, better pre-processing, in that case, you can tune that particular model. If you do tune that particular model, in that case, model might perform well. Here, these many misclassified cases will be having. We have tuned a little bit. In that case, now we have very small amount of misclassified cases. That is, we'll be calling it as best fit or good fit. Good fit. And here it is, you can see it is going through each and every data. It is not learning any pattern. It simply copied or by-hearted that particular data patterns. So it will simply go through each and every data pattern. So it is not possible. This pattern we won't be having. In that case, we'll be calling it as overfitting. So we'll be calling it as overfitting. So this is different variants. What is the overfitting? What is the underfitting? What is the difference between them? Where exactly we'll be using? How can we avoid? When it comes to how can we avoid those underfitting and overfitting, we can simply use regularization techniques. When it comes to underfitting, on training data itself, it is not performing good. In that case, what happens? Whatever the feature that you are taking may not be giving enough information to the prediction. whatever the feature that we are taking into the data set might not be giving enough information to do the prediction of that particular output. So to avoid that, what you have to do, we have to add that feature, add the feature, appropriate feature, which are giving good information. I mean, good information so that we can predict the output. Yeah. So this is all about different pre-processing techniques and when different supervised techniques or machine learning models. What are the different machine learning models we'll be having? One is supervised, one is unsupervised. How can we do the splitting of that particular data? When it comes to unsupervised, we don't need to do any splitting. We can directly feed the data into machine learning algorithm. When it comes to supervised data and supervised machine learning algorithm, what we have to do? We have to split the data frame into train and test. Once it is done, we will train them. We'll train the machine learning model using the train data, and then we will supply the test data to check whatever the machine learning model that we are building is performing well or not. When you have a numerous, high number of parameters, in that case, what we will be doing, we'll be introducing one validation data set. Using the validation data set, we'll be checking at which parameter it is performing well. So we'll be checking all those things. Once it is finalized, where exactly we'll be having the good accuracy, at what parameter we'll be having the good accuracy, then we'll be supplying the test data to check the accuracy of that particular model at that particular parameter. If it is giving good, in that case, we'll be simply going with deployment. And then obviously we'll be checking the overfitting and underfitting. If we have any overfitting and underfitting, we'll go through hyperparameter tunings and we'll simply tune those parameters. And if it is performing well, in that case, we can say whatever the accuracy that we are getting is good accuracy. So this is all about today's session, guys. We have simply gone through what are the different machine learning algorithms we have. How can we do the model evaluation? What are the underfitting and what are the overfitting? And what are the CRISP-ML methodologies? How one data science project processed? What is the sequence? What is the phases of the data science project that we have seen? In the next class, we'll be going with pre-processing techniques. What are the different pre-processing techniques we'll be having when it comes to structured data, and when it comes to unstructured data, what are the difference we'll be having? How can we do the pre-processing? What are the different pre-processing techniques we'll be having? That we'll see in the next session. And yeah, thank you for joining for this session, guys. If you want to continue this series, you can simply subscribe to the 360DigiTMG channel. And if you want to kickstart your data science careers, you can simply subscribe to 360DigiTMG channel, and you can go through the Python series. Or else you can simply search tame Python sessions by Bharani. You will be getting 22 hours of Python session. You can simply start learning the Python session. Yeah, that's it for today, guys. Thank you for joining, and we'll see you in the next session, and have a nice day.